Hello, Kritika. All right, let's start a session. I think no one else is joining now. Okay, first question is on your screen. A capacitor of capacitance C is connected with a battery of EMF E as shown. After full charging, a dielectric of same size of capacitor, remember it is the same size, and dielectric constant K is inserted. Okay, so choose correct options. And remember, capacitor is always connected to the battery, it is not removed. All right, so tell me out of these four options, which one looks correct? Yes, yes, that's the right answer. Yes, Mr. Right answer. All right. When the dielectric is inserted inside this capacitor and its dielectric constant is given as K, right? So the new capacitance of this will become CK, right? Then the charge on capacitor will become, we know that Q equals to CV. So the new charge on capacitor will become CK into V because the battery is not removed, so it will supply extra charges. V over here is epsilon, so this will become CK epsilon and not C epsilon. Now, energy on capacitor decreased. No, it will not get decreased. The voltage is still the same, so the energy will remain the same. Electric field between plates of capacitor increased. No, it will not increase. The charge on the plates will increase and the dielectric will create a decreasing effect. So both of them will compensate. So electric field will remain same. So A will be the right answer. All right, let's move on to the next one. ये आ गया सबको समझ में? All right. A capacitor is connected to a battery. The force of attraction between the plates when the separation between them is halved. No, Kritika, that's not the right answer. Anyone else? No one? Do you need more time or shall I proceed with the solution? Alright. See, what's happening over here is the distance is being halved. Alright. So if distance is halved, that is 1 by 2, then we know that C equals to epsilon naught A by D. So C will become half. Alright. And when C, no, I'm sorry, C will become doubled. And if C is doubled, then the charge on the plates will get doubled. Alright. And we know that force is directly proportional to Q square, right? So because of that, force will become 4 times. Alright, therefore C is the right answer. आ गया सबको समझ में? Alright. Next question. If there are n capacitors in parallel connected to V volt source, then total energy stored is equal to. Yes, that's the right answer, Nishchay. Anyone else? Yes, Kritika, right answer. Yes, do you need more time to solve? Or shall I proceed with the solution? Alright. There are n capacitors in parallel, alright, connected to V volt source. Suppose, oh sorry, these are capacitors. And these are connected to a V volt source. Suppose these are N. So when capacitors are connected in parallel, their resultant gets added up. All right. So suppose these are all C. So for n capacitors, the total capacitance will become n into C. All right. And this is connected to a battery V. And now the total energy stored is being asked. We know that energy stored in a capacitor is equal to half C into V square. All right. So half NC into V square. So that gives us the option B as the answer. आगे समझ में? Shall we proceed? Okay. All right. There is an air-filled 1 picofarad parallel plate capacitor. When the plate separation is doubled and the space is filled with wax, the capacitance increases to 2 picofarads. So now they are asking what is the dielectric constant of the wax. Yes, yes, right answer. No, Nishchay and Kritika wrong answers. Yes, Kritika, that's right. All right, shall we proceed with the solution? Okay. See, suppose there is a parallel plate capacitor C. Now, if the separation is doubled, then the capacitance will become C by 2. All right. And the space is filled with wax. So now a dielectric has been inserted, and when a dielectric is inserted, the capacitance become K times, so it becomes CK by 2. And its value is given as 2 picofarads. All right. 2 pico 2 picofarads. And C we have as 1 picofarads. So 1 K upon 2 is equal to 2. So this gives us K equals to 4. So B is the right answer. Alright, clear है सबको? Shall we move ahead? Alright. For the circuit shown in the adjoining figure, the charge on 4 microfarads capacitor is. No, Kritika, wrong answer. Shall we proceed with the solution? Alright, take your time. Alright, let's proceed with the solution. See, this can be solved in a very easy manner. We want to calculate the charge on only 4 microfarads capacitor. That means only this one. Alright. So what do we have to do? We'll take the voltage. We know that 10 volts is over here, so that means at this at these points the difference is 10 volts, as well as at these points also the difference is of 10 volts. So if we consider just this branch, the voltage drop is 10. This is 4, this is 1, this is 5. So if we calculate the total charge that is entering in this whole branch, then we'll able to find the charge on this capacitor, right? So what is the total charge inside this branch? Let us suppose it is Q, all right? So Q, it is coming over here, and if we simplify the circuit, this is 4 and this is parallel connection, so this will become 6. So here is Q, and this capacitor also gets Q charge. So we know that the potential drops successively after each one. So we can say V equals to Q by C, right? So for each of them, it will become Q by 4 and Q by 6. And if we add up both of them, they should come equal to 10. We have equated the voltages. Alright. So if you solve this, what will we get the answer? This will be 6Q plus 4Q upon 24 equals to 10. And that gives me 10Q equals to 240 and Q equals to 24. And we are using micros, so microcoulombs. So guys, C will be the answer. इसमें ये 3 माइक्रोफैराड्स वाला जो कैपेसिटर वाली ब्रांच है इसका कोई रिलेशन नहीं होगा, because this is parallel connection, so 10 volts gets, like 10 volts appears on both of the branches equally. All right. आगे सबको समझ में? किसी को डाउट हो तो पूछ लेना. यश निश्चय आगे समझ में? All right. Okay. Next question. In the given figure, find the equivalent capacitance between A and B. Anyone with the answer? Yes, that's the right answer, Kritika. All right, see. Shall I proceed with the solution or do you need more time? All right, I'll proceed with the solution then. See, there's a concept used to solve these type of circuits in which it is just like a Wheatstone bridge, or you can say an extension of Wheatstone bridge, in which if you view the circuit from the direction of A, all right, and if you view the circuit from the direction of B, then if it appears the same, then you can remove the line of symmetry in the middle, all right. बीच वाली लाइन पे जो डिवाइसेस आते हैं उनको आप रिमूव कर सकते हैं. So this simplifies to, all right, this is C, 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 and C, C. So if you simplify this further, now it is very simple. This branch will become C by 2 and C by 2 and C by 2. And there are C by 2's in parallel and there are three of them. So it will become 3 into C by 2. That gives us C as the right answer. आगे समझ में? Is there any doubt? All right. Okay, so two plates are 2 centimeters apart. A potential difference of 10 volts is applied between them. The electric field between the plates is. Yes, Nishya, right answer. Anyone else? Shall I proceed with the solution? All right. See, we have a very basic formula that is electric field equals to potential difference upon the distance between them. Alright, that's it. You just have to substitute the values in this. So this is 10 volts upon 2 centimeters is 0.02 in SI units. That will give us 500 as the answer, which is the option B. आगे समझ में सबको? Alright. The charge on any one of the two microfarad capacitors and one microfarad capacitor will be given as, like, these are written in pairs. All right, so the first number is the charge on 2 microfarad capacitor and the second number is on the 1. Yes, that's the right answer, Kritika. Yes, yes, right answer. Yes, that's the right answer. All right, let's proceed with the solution then. The resultant of this circuit can be drawn as, this is 1 and this is again 1, and we have connected a potential difference of 2. All right, so the capacitors are equal and the total is 2 microfarads. So total charge given out by the battery is Q equals to CV, that is 4 microcoulombs. And this 4 microcoulombs will get divided into both of the branches equally because of equal values. So it will be 2 and 2. So D is the right answer. Alright, this is an easy question. The net charge on a condenser is nothing but a capacitor. Yes, yes, right answer. Anyone else? Yes, Nishya, right answer. Shall I tell the solution now? Alright. Net charge on a condenser, that is a capacitor. See, whenever we use a capacitor, always on one side there is a positive charge and another side is a negative charge of the equal magnitude. So net charge, that is the total charge over here, is plus Q and minus Q, that is 0. So D is the answer. Alright? Okay. The last question for today. A capacitor of capacitance 4 microfarads is charged to 80 volts, and another one with 6 microfarads capacitance is charged to 30 volts, and then they are connected together. They are connected with positive to positive terminal and negative to negative terminal. All right. Then the energy lost by the 4 microfarads capacitor is. All right. Suppose these are the capacitors which we have connected. This is 4 and this is 6. Then we have connected the positives to each other and negatives to each other. All right. Then you have to find out the energy lost by just this one capacitor. Anyone? क्वेश्चन आ गया ना समझ में सबको? किसी को अगर क्वेश्चन ना समझ आया हो तो पूछ लेना. No निश्चय wrong answer. Alright, I'll give you a hint. See, how do we find the energy of a capacitor? The energy of a capacitor is given by half CV square. Alright, and now what is this happening in this process? The voltage is getting changed in the process. Alright, when we connect two different capacitors which are charged, then they both come to a common potential. So, what do we have to do to find the energy lost? We will calculate the initial energy of this 4 microfarads capacitor and find its difference with the final one. Alright, अब try करो. Shall we proceed with the solution? Alright. See, now we have the initial voltage in this case, we have the capacitance as well. What do we want to find? We want to find the final potential of this arrangement. So, how do we find that? The resultant potential is calculated as C1 V1 plus C2 V2 upon C1 plus C2. Alright, इसकी वैल्यू क्या आ जाएगी? 320 plus 180 upon 10. Alright, that will give me 50 volts. So our final potential has come, that is 50 volts. So we can find out the energy difference for 4 microfarads capacitor. That will be delta E equals to half C. We can take C common, and then final, initial, we'll take initial first, that is 80 square and minus 50 square. Right, C is 4. So half into 4 into 6400 minus 2500, and we have a 4 micro over here. So that is just 10 to the power minus 6. Alright. So that gives us 2 into, ये कितना हो जाएगा? 3900. That is, alright, that will give us 7.8 millijoules. That is the option A. आ गया समझ में सबको? किसी को डाउट हो तो पूछ लेना. All right. All right, guys, that's all for today. Thank you for joining.
Thank you, sir.
All right, good night.